Let's solve a projectile motion problem involving a ball launched from a cliff. A ball is launched from a 50-meter high cliff at 20 meters per second with an angle of 40 degrees above horizontal. We need to find how far it lands from the cliff base. Let's list all the information we have about this problem. The initial height is 50 meters above the ground. The initial speed is 20 meters per second. The launch angle is 40 degrees above the horizontal. We'll use gravity as 9.8 meters per second squared. First, we need to split the initial velocity into horizontal and vertical components. The horizontal component equals v0 times cosine of theta. That gives us 20 times cosine of 40 degrees, which equals 15.32 meters per second. The vertical component equals v0 times sine of theta. That gives us 20 times sine of 40 degrees, which equals 12.86 meters per second. Here we see how the initial velocity vector splits into horizontal and vertical components. Now we need to find how long the ball is in the air. We'll use the kinematic equation for vertical motion. The vertical position equals initial height plus initial vertical velocity times time minus 1/2 gt squared. When the ball lands on the ground, the vertical position equals 0. So 0 equals 50 plus 12.86 times t minus 4.9 times t squared. Rearranging, we get 4.9 t squared minus 12.86 t minus 50 equals 0. We'll solve this using the quadratic formula. T equals 12.86 plus or minus the square root of 12.86 squared plus 4 times 4.9 times 50, all divided by 2 times 4.9. That gives us 12.86 plus or minus the square root of 165.38 plus 980 divided by 9.8. Simplifying, we get 12.86 plus or minus 3.83 divided by 9.8. Taking the positive solution, we get t equals 4.76 seconds. Now we can find the horizontal distance traveled. Remember, the horizontal velocity remains constant throughout the flight. The horizontal distance equals horizontal velocity times time. That's 15.32 meters per second times 4.76 seconds, which gives us 72.9 meters. Let's visualize the complete trajectory of the ball. Here's the trajectory showing the ball starting at 50 meters height and landing 72.9 meters from the cliff base. Let's summarize our complete solution. The horizontal velocity component was 15.32 meters per second. The vertical velocity component was 12.86 meters per second. The total time of flight was 4.76 seconds. The horizontal distance traveled was 72.9 meters. Therefore, the ball lands 72.9 meters from the base of the cliff.